Hello viewers, in today's class we are going to discuss one important definite integral involving absolute value function, right? So here we have to evaluate the function mod of x cube minus 3x square plus 2x from minus 1 to 2, right? So here this sign denotes the absolute value function, and inside these two lines we have a cubic function, right? We have a cubic function, so the degree of this function is 3, right? So now we have to evaluate this integral from minus 1 to 2. So let us start. So let us call this integral as I, right? Now let us put f of x is equal to x cube minus 3x square plus 2x, right? So here we'll assume f of x is equal to x cube minus 3x square plus 2x, right? Now see here our first step is to factorize this cubic function. So what we will do, we'll take x common, so we have x square minus 3x plus 2, right? Now here we see that this is a quadratic polynomial, and we can factorize it by the method of splitting middle term, right? So here we can write this expression as x square minus 2x minus x, and here we have plus 2, right? Now we can write it as x minus 2, and here we have minus 1 and x minus 2, right? So now taking x minus 2 common, so we have x minus 2, x minus 1, right? So viewers, here we see that this cubic polynomial is factorized into 3 linear polynomials, right? So we can rearrange it like this: x minus 0, here we have x minus 1, and here we have x minus 2, right? Okay, so now here let us now solve the equation f of x is equal to 0, right? So we are solving this equation to find out the critical points, right? So f of x equal to 0 gives us x minus 0, x minus 1, here we have x minus 2 is equal to 0. So now if we solve this equation, we'll get 3 roots: 0, 1 and 2, right? So the zeros of this cubic polynomial are 0, 1 and 2, right? Now let us take the number line. So if we take the real number line, say here we have minus infinity, here we have plus infinity, right? Now what we will do, we'll plot these 3 points on this real number line. So here we have 0, 1 lies somewhere here, and 2 lies somewhere here, right? And now let us take the limits. So here x varies from minus 1 to 2, so minus 1, it lies somewhere here, right? Okay, so now we see that here the roots of this equation are 0, 1 and 2. So these 3 roots divides this real number line into 4 intervals, right? Into 4 intervals, because we know from the theory of increasing and decreasing functions that if we have a function like this, fx is equal to k times x minus alpha, x minus beta and x minus gamma, right? So here f of x is of this form, So here we have 1, here we have 1, and then we have x minus 0, x minus 1, and then we have x minus 2, right? So now here f of x is of this form, where alpha is 0, beta is 1, and gamma is 2. So we have 3 roots. So when we have a function like this, then it divides the real number line into 4 intervals. So we have 3 plus 1. So 3 is the number of roots, and 1 is from the result, that is the theorem, right? So from the theory of increasing and decreasing functions, we know that if an equation f of x equal to 0 has n roots, right? If it has n roots, then it will divide the real number line into n plus 1 intervals, right? Okay, so here we are talking about the real roots. So here we have 3 roots, and so we have n plus 1 intervals. So n is 3 because 3 roots, and 1 is from this result, right? Okay, so now once we have established that these 3 roots divide the real number line into 4 intervals, let us display the intervals. So we'll start from this portion, right? So first we will start from positive sign, then alternatively negative, then positive, and then negative, right? So here if we write this minus 1 after displaying the intervals in which this real number line is divided, so here we have positive sign, then we have negative, then we have positive, then we have negative, right? So we have 4 intervals, and the intervals are 2 to infinity, then we have 1 to 2, then we have 0 to 1, and then we have minus infinity to 0, right? So now here we have these 4 intervals, and here we should start from the positive sign, then negative, then positive, and then negative, because this is a standard result in theory of increasing and decreasing functions. So we are not going to discuss it right now because we have already discussed it in our earlier video. So now let us focus on these 4 intervals. So in this interval 2 to infinity, this function f of x is positive, right? And in the interval 1 to 2, f of x is negative, and in this interval f of x is positive, and here f of x is negative, right? So now viewers, here we have assigned the sign to this function f of x as positive, negative, positive, negative in these intervals. We can also verify the sign of this function in these intervals by taking some particular values. So let me verify it for the sake of better understanding. So let us take the first one. So here we have 2 to infinity, and between 2 to infinity we can take, say, x is equal to 3. Now if we substitute here x is equal to 3, then f of 3 is equal to 3 times 3 minus 1, 3 minus 2. So we see that this is positive, this is positive, and this is positive, and the entire product is also positive, right? So here we are not interested in the numerical value, but we are interested only in the sign, right? Now let us take this interval. So 1 to 2. So here let us take x is equal to, say, 3 by 2, that is 1.5. So f of 3 over 2 is 3 over 2. Here we have 3 over 2 minus 1. Here we have 3 over 2 minus 2. So we have 3 over 2, and this is half, and here we have minus 1 over 2. So this is positive, this is positive, and this is negative. So the product is negative, right? Okay, now let us take the interval 0 to 1. So here let us take the number, say half. So f of half is equal to half. Here we substitute x equal to half. So half minus 1, then we have half minus 2, and here we have half, here we have minus half, and here we have 2 to the 4, 1 minus 4, that is minus 3 over 2. So we have positive, this is positive, this is negative, this is negative, and the product is positive, right? And let us take the fourth one. Here we have minus infinity to 0. So let us take, say x is equal to minus minus 1, right? So here f of minus 1 is now equal to minus 1, and then we have minus 1 minus 1, then minus 1 minus 2. So here we have minus 1, here we have minus 2, and here we have minus 3. So now this is negative, this is negative, this is negative, and the product is negative, right? So here we have negative. So this is how we can establish, or we can verify the sign of f of x in these 4 intervals, right? So before integrating this function, we have to do all these things. So now viewers, let us now display our this limit here. So minus 1, it lies somewhere here, right? And now we have to integrate from minus 1 to 2, right? We have to integrate from minus 1 to 2. So what we will do, we'll break our integral I into the sum of 3 integrals. One is from minus 1 to 0, the second one is from 0 to 1, and third is from 1 to 2, right? Now f of x, mod of f of x is equal to negative, right? Negative of f of x whenever see x belongs to, right? Whenever x belongs to minus infinity to 0, right? So now here we are writing this definition of absolute value function by using the definition which says that mod of x is equal to plus x whenever x is greater than or equal to 0, and minus x whenever x is less than 0, right? Okay, so now here mod of f of x is equal to negative of f of x whenever x belongs to this interval, right? And when f of x, mod of f of x is equal to positive f of x whenever x belongs to this interval, that is from 0 to 1, because here we have the positive sign, and from minus 1 to 0, which is equivalent to minus infinity to 0, because we are taking the entire interval from minus infinity to 0. So here we can also write minus 1 to 0, right? And mod of f of x is equal to negative of f of x whenever x belongs to this interval, that is from 1 to 2, right? So now we have the sign of mod of f of x like this in these 3 intervals, and here we have to split this integral I as a sum of 3 integrals, right? So I1 plus I2 plus I3. So I1 is from minus 1 to 0, and here we have mod of f of x dx, and I2 is from 0 to 1 mod of f of x dx, and here we have 1 to 2 and mod of f of x dx, right? So here we see that uh, we have the points 0 and 1 where we have to break the limits, right? So first is from -1 to 0, and then 0 to 1, and then 1 to 2. Now we can write -1 to 0, and when we have x belonging to -1 to 0, mod of f of x is equal to minus f of x, right? And when x belongs to 0 to 1, we have mod of f of x is equal to positive f of x, right? And when we have 1 to 2, then mod of f of x is equal to negative of f of x and dx, right? So now our aim is to solve these three integrals, right? And where f of x is given by this cubic polynomial. Now viewers, I1 is now given by this integral. Here f of x is this polynomial, and now we can write -1 to 0. Here we have minus x cube plus 3x square minus 2x and dx, right? Now we can easily integrate these three terms. So we have minus x cube is x raised to 4 over 4, then we have 3x cube over 3, and then we have 2x square over 2, right? And the limits are from -1 to 0, right? So the integral of x cube is x raised to 4 over 4, x square is x cube over 3, and x raised to 1 is x square over 2. So now we can rewrite it as x raised to 4 over 4 plus x cube, and then we have minus x square, and the limits are from -1 to 0. Now let us substitute the limits and we'll take the difference. So when we take 0, then all these terms become 0, so we have 0 here minus, and when we have x is equal to -1, then we have -1 over 4 minus 1, -1 cube is -1, and -1 square is +1, so we have -1. So this is if we solve it, then we have 9 over 4, right? Now let us take the integral I2. Now I2 is given by 0 to 1 plus f of x, and f of x is given by this polynomial. So now again integrating this function like this, we have x raised to 4 over 4, then we have minus 3x cube over 3 and 2x square over 2, and the limits are from 0 to 1. And now taking x equal to 1 over here, so we have 1 over 4 minus 3 and 3 get cancelled, so 1 cube is 1 and 2 get cancelled, 1 square is 1, and then we have 0, so all these terms become 0, and now minus 1 and 1 get cancelled, so we have 1 over 4, right? Now let us take the integral I3. So I3 is from 1 to 2, and the sign of f of x is negative here, so f of x is x cube minus 3x square plus 2x, and here we have dx. Now we have 1 to 2 minus x cube plus 3x square minus 2x dx, and here the integral is minus x raised to 4 over 4 plus 3x cube over 3 minus 2x square over 2, and the limits are from 1 to 2, right? So now 3 and 3 get cancelled, 2 and 2 get cancelled, and if we take x is equal to 2 here, then we have minus 2 raised to 4 is 16, so we have minus 16 over 4, and here we have 2 cube, that is 8, and here we have minus 2 square, that is 4. And when we have x equal to 1, we have minus 1 over 4. Here we have 1 cube, that is 1, and here we have 1 square, that is 1, right? So here 4 4s are 16, so we have minus 4, 8 minus 4 is plus 4, and here we have 1 and minus 1 get cancelled, so we have minus 1 over 4, and now these two get cancelled, so we have 0 and minus minus plus, so we have 1 over 4, that is 1 over 4, right? So viewers, here we see that the value of I1 is 9 over 4, I2 is 1 over 4, and I3 is 1 over 4. So the value of this integral I is I1 plus I2 plus I3. So we have 9 over 4 plus 1 over 4 plus 1 over 4, and this is 9 plus 1 over 4, that is 11 over 4, which can also be written as 2 and 3 over 4, right? So this is the mixed fraction, right? So viewers, this is how we solve this interesting problem.